Let's summarize what we've learned in this lecture. MATLAB supports a number of operations between matrices and scalars and matrices and matrices. In the case of a matrix and a scalar, what happens is that the scalar is applied to every element of the input matrix, and those results are placed into the corresponding elements of the output matrix. The sorts of operators we can use between a matrix and a scalar include the standard arithmetic operators, and they also include the logical operators, which perform logical comparisons and which have a result which is either true or false. When we perform an operation between a matrix and a matrix, the matrices need to be the same size, and the operations are performed between corresponding elements of the matrix. The results are placed into the corresponding element of the output matrix. MATLAB supports a number of logical operators. The results of a logical operator are only true or false, and we can perform a number of different logical tests: equality, non-equality, greater than, less than, and so on. We've talked about monadic image processing, and that is where individual pixels in the input image are passed through a function, f of x, and the result is placed into the corresponding element in the output matrix. We apply the same function to all pixels, and we looked at a number of operations such as contrast enhancement, brightness change, histogram normalization, thresholding, posterization, and so on. There are many, many more. The other class of operation we looked at are what we call dyadic operations, and here we have two input images passed through a function, and the output value is placed into the corresponding pixel in the output image. Some examples of dyadic operations were image subtraction, which we used to find the difference between two input scenes. We also used a number of different dyadic operations in performing quite a sophisticated image processing task, which is implementing the green screen effect.